Analyzing graphs can give people some fits. You have to really process it, think about it, switch your brain. So you can't just rush through these. You're going to have to really be processing. It's not really a memorization kind of thing. A little bit of memorization though. First we have domain and we have range. So just a reminder that domain are your x values. So we're going to be focusing on the left and the right. And then your range, those are your y values. And I don't think this is all new to you. You know that. And we're going to be focusing on the up and the down. Okay, so domain is left and right, range is up and down. So if we look at this first example here, focusing on the left, we're going to figure out what is the domain of this red graph. So my leftmost value, we read a graph left to right whenever we're talking domain. So the leftmost value on this one, it's kind of hard to see, but trust me, this is a -7. And you see how that's a solid dot? So I can write -7 with the square bracket. And then how far does it go over to the right? It goes to this point right here, and that x value is 8. Again, it has a solid dot, so I'm going to use a square bracket. Okay, now range. Range we read bottom up, okay? Bottom up for the range. So the lowest value on my graph, right there, and that value is, if you could see the graph better, it's at -5 or -6, I'm sorry, the lowest value is -6. And then what's the highest value? Not where does it end, but what is the highest value that it goes to, which is right here at this point, and that value is 5. And we do a square bracket because it doesn't have an open circle on it. It actually hits at 5. Let's go to the right and try this one. So our domain, the leftmost value, we can actually see the grid on this one is -5. And again, it has a square bracket, so -5. And then how far to the right does it go? Well, can you see that it doesn't end? That it kind of looks like it stops at 5. So this is one of those kind of questionable ones. It looks like it's not going to go past 5, but it's going to get really, really, really close to it. So I'm going to do 5 with a curvy bracket, or I'm not really sure. Is it going to go past 5? Maybe we could put infinity. I can't really tell 100%. Then on the range, this is when we read bottom up. The lowest value on our grid, it looks like it's -infinity. See how it just keeps on going down there? And what's the highest value that it goes to? Right up here at +5, and it includes it. So looking at some other examples here, not just the notes examples. I'm going to find the domain, the range, and the 2 actual values. So domain, reading it left to right. Well, it looks like on this one, I don't see arrowheads, but I don't see dots either. So we're going to assume that these mean arrowheads here. So it's going to continue. I mean, there's no ending on the left-hand side. So that's going to be a -infinity and to a +infinity. Now our range, bottom up, what's the lowest value? I see arrowheads. So that's going to be a -infinity. And how high up does it go? Right here to 3. And it does include 3, so we're going to use a square bracket. And then let's find f of 0. So it means, what is the y value when x is 0? So find where x is 0. What is that y value? That is 3. And what is the y value when x is 3? So when x is 3, right here, there's our y value of -6. Next, example 2, let's find the domain. Okay, left to right. Again, I don't see arrowheads, so we're going to put arrowheads on there. And it looks like it continues on going to the left forever, so -infinity. It does have all values, even though there's an open circle at 1, because there's a closed circle above it at 1, we have the value of 1. X is 1 somewhere. And then it looks like it keeps going to the right forever, so that's going to be an infinity also. Now for our range. Lowest value is at -2, does not include it, so we're going to use that curvy bracket. And then it looks like it takes on all values and it just keeps on going up forever. Next on part C, let's find f of 2. So the x value is 2. What is the y value? Right there. Y value is 0. f of 1. So when x is 1, we don't have a y value at negative 2 because it's an open circle. So we're going to have to use this solid dot. So that is going to be a 1. F of 3, when x is 3, I'm going to eyeball that one and call that one 2. And then f of negative 1, also going to eyeball that one. That one kind of looks like it's up at 3. All right, looking at zeros. Zeros is just a term. It's just a vocab word. Zeros occur when the function crosses the x-axis. So zeros are the same thing as our solutions. Whenever we're solving for x, that's all we're finding is where our graph crosses the x-axis. Or we can also say touches. It doesn't have to physically cross and go from one side to the other. So the zeros to the right are negative 1, 1, 3, and 4. Even though 3 doesn't cross, it's still a 0. So whenever you see find the zeros of the function, it just means solve it. And our y value is equal to 0. Wherever x on the x-axis, our y is 0. So we'll just set our equation equal to 0. Oh, this isn't a happy one. Okay, so we want to multiply to get a negative 48. We want to add to get 13. Well, I'm thinking 4 and 12. Nope. How about 3 and 16? There it is. Okay, 2x squared plus 16x minus 3x minus 24 equals 0. 2x times x plus 8 minus 3 times x plus 8 is equal to 0. 2x minus 3 and x plus 8. Oh, it works out perfect, doesn't it? Because my parentheses matched. X in would equal 3 halves. X is a negative 8. So those would be considered our zeros. Next, we'll take the square root of t minus 25 and set that equal to 0. I want to get rid of that square root, so we'll square both sides. T minus 25 is equal to 0, or t is equal to 25. It looked like it was going to be ugly, but it sure wasn't. On example 3, we'll set equal to 0, our equation. Now on this one, we need to get rid of that denominator, right? So I'm going to multiply both sides by that denominator. So on the left-hand side, it's gone. We're left with x squared minus 2, and then 0 times anything is 0. That's really pretty easy, right? So we'll add 2 over. X squared equals 2. Square root both sides. X equals a positive square root of 2 or a negative square root of 2 for our answers. All right, that's just taking care of graph with domain and range. Be patient with it. And I have to actually move my hand whenever I'm reading these.